Ordinarily, when you are given a problem like this, you will want to be moved as to how to deal with it. But oftentimes, what I like to do is to go back to the basics. And this is pure physics and pure electricity, just nothing special. But I want to take your mind back. If this were to be, let's say this were to be a circuit, an ordinary basic circuit, what I you would do first of all. So we are asked, it said, given that impedance Z1 equals to 4 angle 50 squared, Z2 is this and Z3 is this. They are all in ohms. If Z1 and Z2 in series are connected in parallel with the Z3 across a 240 volt, 50 hertz, find the first one says the total impedance of the circuit expressed in both rectangular and polar form. Now, I want to assume you already know how to use your calculator to interplay between polar form and rectangular form. These are forms in which you can express um, values in electrical engineering. Now, the supply and the branch current, that's the second question. The third one is what value of impedance will be conducted. Well, let's leave this thing that looks jangles. Let's take your mind back. Let's see if we can construct the circuit. Now, what I'm basically having here is something like this. It said Z1, if Z1 and Z2 in series are connected in parallel with a Z3, Z1 and Z2 in parallel. So I can have something like this, Z1, Z1, I have something like this, Z2. Okay, so I have something like this in parallel with a Z3. Okay, so you have something like this. Now, when you say parallel, of course, you know what that means. It's side by side. So this is it. All right. But how do we deal with this system? It's as basics as how we do electricity. If I take your mind back, if there to be a resistor, let's say this is a normal resistor. Forget the big values they are calling for you, but the rectangular and complex form they are making it seem. Let me take your mind back to, so if I have, let's say, 4 ohm. Let's say if I have let's say 3 ohm. Let's say if I have 4 ohm. Okay, let's say 6 ohm here. Sorry. So if this is going to be, what I'll have is, let's say this is the case will be here. Let's say it's connected across a 240 voltage. 240 voltage. Okay, 50 hertz. Okay, now if you are connected like this, if you are asked to find in this question, then you ask the total impedance, the total resistance in this circuit, how is going to be? Normally, I'm going to be the summation. The first, these two are in series, right? So I'll first to add them up. That's 4. Sorry, not 4. 6 plus 3. That's what? 9 ohm, right? Why this one is in parallel with this? The 4 ohm is in parallel with this combination of this. So it's going to be this is the resistance in series. Okay. Now for total resistance ROT, we can use parallel law of resistance combination. So I can have 9 times 4 over 9 plus 4. And 9 times 4, that gives me 36. Okay, over, that's 18, yes, 36 over 9 plus 4, that 9 plus 4 is 13. Okay, so basically this becomes my ROT. Now, that is what I want to do in this first question. They want to determine what? They want to determine the total impedance of the circuit expressed in both rectangular. So just do the impedance. To convert to rectangular and polar form, what you need to do is just to use your calculator when you get your answer. Alright, nothing special. Then the second one, the supply and branch current. Now, first of all, I need to compute what this. So we're asked to find, let's say, the supply current. Now, the number 2 part, the supply current. If this question was to be what is going to ask, the same thing. Supply current will be I is equals from Ohm's law V over R, which is what's my voltage is 240 over what's my resistance 2.78 ohm. So if I punch that, I have 240 divided by 2.78. That's going to give me 86.3. So 86.33 ampere. So that's the current that will drive to here. So I that will come through from this place down is going to be, let's say, it's going to be 22.3. Sorry, 86.3. That's going to flow through here. Now, that being said, so to find the current, the supply and branch current, the supply current is already this. Now, to get the branch current, when this current comes here, it's going to split into one come here. So I'm going to have IA. Can I call here IB? Alright, so it's going to branch here, it's going to branch here. Now at the end of it, or the current is going to meet back in this place to give me 86.33. Do you get the idea? So for me to get the current that branches here, it's going to be dependent on the resistance that flows in this path. Okay, the resistance will determine the current that will flow here. So in this case, now let's calculate the current. So current, total resistance already we have seen in these places. Let's say I in the series, let's call it series, the current that flow on the first top one, this one, is going to be 3 plus, so already said the total, we already know it. Voltage is 240 because the same voltage that will flow through them. Alright, same voltage. So I have over, what's the current here? Current is 86, sorry, resistance is 9. Okay, so I'm going to have 240 divided by 9, now give me 26.6 ampere. That's what will flow at the top. Now for the bottom part of the current that flows to the bottom, I bottom, let me use that, is going to be 240 divided by 4 in that case, because that's the resistance, and that will be about 60 ampere. Now if you add these two together, let me change the pen please. If you add these things together, you're going to have 86.33 ampere, which is the sum of the whole of this thing. Nothing special. Alright, let's go straight to that question. Now that we get the idea, let's solve this question. But before we solve this question, there's a little bit of trick the questionnaire or the examiner wants to tempt. He wants to know if you understand. That's what's called De Moivre's theory. What is the De Moivre theory all about? It simply says that now we're faced with the same problem, but maybe this time around with bigger grammar. Okay, so we're going to use De Moivre's theorem. What does it say? De Moivre says that if for example, expressing theta is, let's say, z raised by n is equal to r raised by n, I'm going to have, this is in cos theta plus I sine theta. It's in terms of math notation, raised by n. What I'm simply saying is that if an impedance is raised by having a certain power, this power will affect both the arrow and the theta. So what I mean is, for example, in this case, you take the root, this becomes the power, this becomes the power, and same the power also is distributed in the cosine and the sine form as well. So it's going to be r raised by n, okay, I sine theta like that. So if we apply it here, so if I apply it to our z1 equals to 4 squared, because our z1 is, remember we said our z1, let me write it out here, is 4 angle 15 degree, all raised power squared, or all raised power 2. So this is, it will affect this square of this, then this will be distributed in the cosine, right? But what happens here is that for the angular part, it's going to multiply it, but for the radius, the arrow part, the unit, is going to square it. So here it's going to be 4 square into cos 2 theta plus j sine 2 theta. I don't know if I can, or spend more time create a video on the mobile story. That's what it's all about. We have to decode that first. That's 16 into cos 30, cos 30 plus j sine 30 degree. Okay, so that's all about. Now, if you convert this to, if you press your calculator, what you need to do is just go to your calculator, press rect, right? Press rect, press, you see a rect by pressing shift, your cash your calculator. Maybe some other time, we can look at the video on that. Press your rect, alright, rect, then you press 16, comma 30, because the first value is the arrow. When you put a comma, the next value is already taken as the angle. So 30, then so this is what I'm saying. Rect 16, comma 30. If you put an equal to sign to convert this thing to a rectangular form, and this is what it will give you. It will give me 13.86 plus J8. Alright, this is it in rectangular form. Then if you do the same thing, your Z2 is also the same problem. We have 125. Okay, this by 1 over 3, open bracket, cos, again I said it multiplies the angle. The same power, 1 over 3 times, what's the theta here, the angle that was given to you, 45 degree, plus J sine 1 over 3 times 45 degree. Okay, so if you put that, this will be, if you pull it out, cube root, this of course from indices it becomes 5. Okay, this will be cos 15, yes, degree, plus J sine 3 into this will give me 15 degree. All right, so that's basically it. Now, if you want to, again, the same process of converting this, you're going to use rec, put this value that you have here. It's going to give me rectangular form, and if I punch that, when I did that now, it's going to give me 4.83 plus J 1.29. This is it in rectangular form. So we're not done. We are still expanding our work. Now already the Z3 is already given to you rectangular form. It's 8 minus J 6 ohms. We will not forget our unit, ohms. Okay, like that. So ohms like that. This is ohm. It's not n. This ohms. This ohms. Okay, thank you. Now let's get to the problem. All we'll be doing is conversion. Let's get to real solve our problem. Now, since we're going to use the same technique, since Z1 and Z2 in series, so the series combination is going to be some Z1. It's where is it now? Okay, I have 13.86 plus J8. The whole of this expense is bad. Okay, I'm coming in just a minute. Plus J8. Alright. Then all of this is that Z1 plus what's my Z2? I have 4.83 plus J 1.29. All ohms. So if you add these two up together, it will give me, using your calculator. Normally what I do is I make life easy. You can switch your calculator to the complex mode. That's pretty simple. There's nothing phenomenal about it. So Z12 combination is going to be this, which is for Adam is going to be 18.69 plus J 9.29 ohms. Right? So this is the combination, it's series combination. We are only there to this top, which is the series. But let's deal with Z3 because we have to find total impedance of the circuit. So we have only found the top. Let's deal with the total impedance. Z total is a combination of Z3, Z12 parallel with Z3. And because they are in parallel, what we'll do, multiply and divide with the sum. So I have Z1, Z2, this one is going to be 18.69 plus J 9.29 times what I have here is 8 minus J6, okay, all over 0.69 I think that's what I'm seeing here. Okay, yes, that's what we got. J 9.29 plus 8 minus J6. So if you deal with these two together, it's going to, if you do multiplication addition, basically it's going to give me 205.26, right, minus J 37.82 all over 26.69 plus J 15.29. If you further divide it, break it down, it's going to be 7.40 minus J 2.33. This is in rectangular form. This is in rect. Now, let me distinguish it so you don't mix them up. This is in rect form. Now, I can convert this to my polar form by pressing calculator. I just press polar, just press pol, put this value, and the x component is 7.40, comma 2.33. It's already told the calculator this is the x, this is the j component, right? So if you do that, your calculator will give in polar form. Or if you want to go through the manual way of converting, I'm sure by now you should be familiar with. But in case you're not, you can drop a comment below. I will explain how to convert these things your calculator or manually using your calculation. So because of time, I'm trying to save this video long period of time. So it's going to be, in terms of polar, it's going to be 7.75, all right, angle minus 17.47 degree. This is in polar because the question says we should find the express it in both rectangular and polar form. So we are done with this part, which is very important. We're done with the first part. Next, we want to define the current that flows through the supply and branch current. Very important. So what we are having here is supply and branch current. First of all, let's deal with the supply current. Supply current will be voltage, which is what we got as voltage. We already were given as 240 plus 0J or J0 volts over what's the total impedance. Let's leave it in rectangular form so it makes our work easier. So it will be 7.40, right, minus J 2.33. So if you work this out with your calculator, of course your calculator should be in complex mode form, right? It's not hard. Go to shift, from there shift, you're going to see options. Use a good calculator. You see complex, press it, all these I and J will be there in your calculator. But in case you're not, you can drop a comment down. I'm going to make a video in that sense, or probably mail me to make it faster. I'm definitely going to respond. So if you have this, it's going to give me 29.50 plus, all right, J 9.29 ampere. This will be the current that you are going to get. Ampere 9.29. This pen is not in shape. So 9.29. This is what you're going to get. All right. Likewise, now for the ones that are in parallel, okay, I'll have to draw the circuit. Now for the individual branches, let's say IA, for example, that's current in the branch A. It's going to be the voltage in that branch. Now, because when circuits are connected in parallel, they have the same voltage but different currents. Now, the current will be a function of the voltage, function of the resistance given or that is present in that branch of the circuit. Do you understand? Here, for example, this voltage across here, and these two sides, they are actually equal, the same voltage here and here. But the thing is that their current is going to differ because of the resistance that each of them is going to bring about. Okay, so current in A will be voltage in A over the impedance in Z12 that's caused by Z12. That's combination of Z1 and Z2, and that will be equal to what's the voltage? When you remember, it's still the same 240 plus J0 voltage over what's Z1, Z2. Remember, if you take your mind back, we calculated earlier on 16.69, 18.69 plus J 9.29. Okay, and that will give me, if you add it up, it's going to give me 10.29 5.29, all right, minus J 5.12 ampere. This is the current, this is the branch current that is going to be present in A. Do you understand? It's going to be present here. Here, this is the branch current that will present here. Now, let's calculate the one that's going to be present here. But the idea is that by the time these two branch, just imagine this 20, the initial current was flowing through, which is 29.50 was flowing through here. It began to it branched into the two aspects. When it comes back here, it's supposed to give me 29.50 back here. If it doesn't, it means you're wrong. So let's go to I current in B, the voltage over Z3, which is the voltage here is 240 plus J0 over what's the resistance offered by that Z3, 8 minus J6, alright, so which is equal to, if you do the math quickly, it's going to give me 19.2 plus J 14.4 ampere. Now if you add this thing to up, you're going to discover it's going to be 29 point something, which means you are correct. That means to say that I am, according to Thevenin's, or according to, yes, not sum of currents, so IM is equal to IA plus IB. This should be. If it isn't, that means something is wrong somewhere. So we've just considered calculating the branch current. Now for us to calculate the third question here, according to this image, it says we should what value of impedance will be connected in series with the supply to limit the source current to 1/3 the calculated source current in part 2. What value of impedance? We don't know the value of the impedance, but we can. And the question says what value of the impedance. Now recall, let's say attending to solve question 3. Maybe I should use another pen, sorry, pardon me. So let's say I'm using this pen. What value of the impedance? Oh, this is even worse. Okay, let's use something different. So we're going to now recall before the effective resistance was introduced. What we have here, the total impedance, Z total, is equal to, before you even think of total impedance of everything, was 7.40, alright, minus J 2.33 ohm. That's the value of the impedance. Now before the unknown resistance X is introduced, we are saying that what value of X to introduce, they'll make the source current. Now what's the source current? Let's go again. Source current is pretty simple, just some small math you have to do. Source current normally, when we checked before, is 29.50 plus J 9.29 ampere. Okay, ampere. Now you see what value of this must be added to this thing to make it 1/3 of it. And 1/3 of it simply means divided by 3. There's no special drama to be acted here. So when we say it's divided by 3, we're going to have recall that normally I is equals to V over Z. So we're going to have what value? That's voltage. We say 240 plus J0. Let's just carry it along, even though it's really not important. So I have 7.40 minus J 2.33 plus X, right? Because this is going to be added X. So total resistance here, if we add there, is going to be X plus 7.40, right, minus J 2.33. Okay, so if you add that, it's going to be we don't know the value, we can solve for it. So it's 29.50, which is the source current, plus J 9.29 all over 3, because we said what value of this to make this 1/3 of the source current. So it's just a thing of solving, which is solving for what this guy is, and then you get your answer. Every other thing is pretty simple, nothing spectacular about it. But in case you're confused and you don't know how to go about it still, even regardless of the explanation I've given, I think we can work that out. Well, basically just multiply 3 times 7, 20 if you want to do that, or if you want to simply divide, whatever way. But it's basically simple. I don't wish this video to extend beyond this point. So, but if you have issues and clarification, I can make another video to explain this theory part. Well, if you can do this calculation, if you can do this simple manipulation in your calculator, all right, every other thing is going to be simple, and the answer you get the value of x. Now, if you do that, the value of x ought to be x is equal to 14.80, right, minus j 4.66 ohm. This is the value of x that will be connected in series to the source current to give connected in series to the circuit to give the source current 1/3 of the value. So once you do that, I think you are good to go. All right, do have a wonderful time, and please find time, if you like, just to subscribe, and it's very important.